Determine the molecular formula for a compound that has the empirical formula CH2O and a molar mass of 180 grams per mole. In order to solve this problem, you need to determine the gram formula mass of CH2O. You can do this by multiplying the atomic mass by the number of atoms in the compound. C has an atomic mass of 12U, H has an atomic mass of 1U, but there are 2 H atoms, which is 2U. O has an atomic mass of 16U. 12 plus 2 plus 16 is equal to 30. If the molar mass was 180 grams per mole, this means it would be 6 times the ratio of the compounds in CH2O because 180 divided by 30 is equal to 6. This means that there will be 6 atoms of C, 12 atoms of H, and 6 atoms of O. The molecular formula will be C6H12O6. Bromine, chlorine, fluorine, and iodine are 4 elements in group 17 that can be differentiated by some of their properties. State the transient atomic radius for these 4 elements as they are considered in order of increasing atomic number. As the elements are considered in order of increasing atomic number, the atomic radius increases. This is because the amount of electron shells will increase, therefore the atomic radius will increase. Determine the mass of a sample of iodine that has a volume of 2.5 centimeters cubed at room temperature and standard pressure. If you turn to the back page of the reference table, you should look at the first formula, D is equal to m divided by V. The density of iodine according to table S is 4.933 grams per centimeters cubed, and it says in the question that the volume would be 2.5 centimeters cubed. The equation can be arranged as 4.933 grams per centimeters cubed divided by times 2.5 centimeters cubed is equal to mass. Mass is equal to 12 grams because there are 2 significant figures in the equation, so the answer should also have 2 significant figures. State in terms of electrons why these elements have similar chemical properties. These elements have similar chemical properties because they have the same amount of valence electrons. When solid calcium carbonate is heated, solid calcium oxide and carbon dioxide gas are formed. The balanced equation below represents this reaction. State the molecular polarity of a CO2 molecule. The molarity of a molecule is determined by looking at the Lewis structure. A nonpolar molecule is symmetrical, while a polar molecule is asymmetrical. CO2 has 2 oxygen atoms and 1 carbon atom. It will be drawn as the C in the middle, bonded to 2 oxygen atoms on either side. Carbon has 4 valence electrons, and oxygen has 6 valence electrons. Since there are 2 oxygen atoms, that means there will be 12 electrons from oxygen, plus the 4 electrons from carbon, providing 16 electrons to distribute, so that each atom has 8 electrons surrounding it. After putting 2 bonds between the atoms, 12 electrons will be left. This is not enough to provide each atom with 8 electrons, so 2 more electrons must be added. This means that 8 electrons will be left. 4 will be around each of the carbon elements. This is symmetrical, so CO2 is a nonpolar molecule. Based on Table S, determine the electronegativity difference between oxygen and calcium oxide. The electronegativity difference is determined by subtracting the smaller electronegativity value from the larger electronegativity value. Ca has an electronegativity value of 1. Oxygen has an electronegativity value of 3.4. 3.4 minus 1 is equal to 2.4. The electronegativity difference between calcium and oxygen and calcium oxide is 2.4. During a laboratory activity, a student dissolves 20 grams of solid ammonium chloride in 100 grams of water at 25 degrees Celsius. After thorough stirring, no undissolved solid ammonium chloride remains. During this laboratory activity, appropriate safety equipment is used and safety procedures are followed. Classify, in terms of saturation, the type of solution produced. This equation is asking if the solution is unsaturated, saturated, or supersaturated. We need to look at Table G in the reference table. Once we find the line with ammonium chloride, we have to align it with the amounts in the question. It says 20 grams of ammonium chloride at 100 grams of water at 25 degrees Celsius. This is below the line of ammonium chloride in the table, so this solution is unsaturated. State evidence from Table 1 that indicates that this dissolving process is endothermic. An endothermic reaction absorbs heat. This means that on table I, the Titration heat will be a positive number, not a negative number. If you look 5 rows up from the bottom of table I, when ammonium chloride is dissolved in water, a positive amount of heat is released, symbolizing that this is an endothermic reaction. State in terms of particle distribution why this solution is classified as a homogeneous mixture. This solution is classified as a homogeneous solution because the particles are evenly distributed or uniformly distributed. You have to remember that this is a definition of a homogeneous solution, and a heterogeneous solution is a solution where the particle distribution is not uniform. Starting as a solid, a sample of a substance is heated uniformly at standard pressure, as shown by the heating curve below. Identify the interval during which the average distance between the particles is the greatest. The heating curve shows a substance as it changes from a solid to a liquid to a gas. The interval EF will represent it being a gas. In a gas, the particles are the most spread apart, so the answer to this question is the interval EF. State what happens to the potential energy of the particles during the melting of the substance. This question refers to the straight line portions of the heating curve. During these intervals, the potential energy will increase because the energy is breaking the bonds that holds the particles together. A 30 milliliter sample of HCl was exactly neutralized by 18 milliliters of 0.1 m KOH. During this laboratory activity, appropriate safety equipment was used and safety procedures were followed. State the color of Bromoscol green indicator if it were added to a sample of the 0.10 m KOH. KOH is a base, as seen by its presence on table L. Bases have a pH value greater than 7. If Bromoscol green was present in a substance with a pH greater than 7, it would be blue, because when pH value is greater than 5.4, Bromoscol green will be blue. State the number of significant figures used to express the concentration of KOH. The problem says that the concentration of KOH was 0.10 m. This is two significant figures because there is a decimal point, which means that the zero after the decimal point is also considered a significant figure. Determine the concentration of the HCl sample using titration data. The formula for titration is molarity of the acid times volume of the acid equal to molarity of the base times volume of the base. HCl is the acid and KOH is the base. We need to find the molarity of HCl. We can set up the problem as molarity of the acid times 0.3 liters is equal to 0.10 m times 0.18 liters. During doing this math, we will discover that the molarity of HCl is 0.06 m. Compare the hydroxide ion concentration of the 0.10 m KOH with the hydroxide ion concentration of the resulting neutral solution. In a neutral solution, the concentration of hydronium ions will be 1 times 10 to the 7th because a neutral solution has a pH of 7. KOH is a base, which means that it will have a pH greater than 7. This means that the concentration of hydronium ions in KOH will be greater than 1 times 10 to the 7th. The concentration of hydronium ions will be greater in KOH than in the neutral solution. Some scientists study samples of ancient ice. A water molecule trapped in ancient ice typically has an oxygen-16 or oxygen-18 atom in its structure. Water with oxygen-16 evaporates slightly faster from seawater than water with oxygen-18. The three naturally occurring isotopes of oxygen have mass numbers of 16, 17, or 18. Compare the number of protons to the number of electrons in the atom of oxygen-18. This question might be trying to trick you if you have forgotten the characteristics of an isotope. An isotope of oxygen, such as oxygen-18, has an atomic mass of 18, whereas the oxygen element on the periodic table has a mass of 16. This means that oxygen-18 has two more neutrons than oxygen-16. There will be no change in the amount of protons or electrons. Therefore, the amount of protons will be equal to the amount of electrons in oxygen-18. In the space in your answer booklet, draw a Lewis electron dot diagram for an atom of oxygen. Oxygen has 6 valence electrons. To draw a Lewis electron dot diagram for oxygen, we must draw the element symbol O with a corresponding amount of valence electrons, 6, around it. State in terms of neutrons why a water molecule containing an O18 atom has a greater mass than a water molecule containing an O16 atom. I already explained this when answering question 66, but an atom of oxygen 18 has 2 more neutrons than an atom of oxygen 16. Potassium superoxide removes carbon dioxide from the air and produces oxygen in space shuttles, as represented in equation 1 below. The heating of sodium hydrogen carbonate causes baked goods to rise when it produces steam and carbon dioxide gas, shown in equation 2 below. Show a numerical setup for calculating the percent composition by mass of oxygen in the sodium hydroxide carbonate. The gram formula mass 84 grams per mole. If you turn to the back page of the reference table, percent composition by mass is equal to mass of part divided by mass of whole times 100. The question tells us that the gram formula mass of sodium hydrogen carbonate is 84 grams per mole. We must determine the gram formula mass of oxygen to set up our equation. On the periodic table, oxygen has an atomic mass of 16U, but there are 3 oxygen atoms, so 16U times 3 is equal to 48U. 48U divided by 84U times 100 is equal to percent composition by mass. It only asks for the numerical setup, so we do not have to calculate the answer. Determine the number of moles of K2CO3 produced when 3.5 moles of KO2 completely reacts, as represented in equation 1. When 4 moles of KO2 undergo a chemical reaction in equation 1, it produces 2 moles of K2CO3. The ratio is 2 to 1. So, if 3.5 moles of KO2 undergo a chemical reaction, then half as many moles of K2CO3 are produced. 3.5 divided by 2 is equal to 1.75. 1.75 moles will be produced. Balance equation 2 in your answer booklet for the heating of NaHCO3 using smallest whole number coefficients. To balance an equation, there must be an equal amount of each element on each side of the equation. On the reactant side of the equation, there is 1 atom of Na, 1 atom of hydrogen, 1 atom of carbon, and 3 atoms of oxygen. On the product side of the equation, there are 2 atoms of Na, 2 atoms of hydrogen, 2 atoms of carbon, and 6 atoms of oxygen. Looking at these numbers, you can clearly see that if we were to multiply the quantities on the reactant side by 2, then the amount of atoms on each side of the equation would be equal. So the coefficient in front of the reactants should be 2. In 1787, Jacques Charles, a French scientist and pioneer balloonist, performed experiments on how the volume of a gas depends on temperature. Using a rigid cylinder with a movable piston containing a sample of helium gas, a scientist obtained data for temperature and volume. The graph below represents the relationship between the temperature and volume of the sample of helium gas at 1 atmosphere. Determine the volume of this sample of helium gas at 350 K. You need to find 350 K on the x-axis and align it with the corresponding number on the line. The number is between 5.5 and 6, so it looks like the volume would be about 5.7 L. Of course, the Regents has an interval that the right answer could be between. 5.7 L is not the only right answer. Compare the average kinetic energy of the helium atoms in the sample at 200 K to the average kinetic energy of the helium atoms at 300 K. As temperature increases, the kinetic energy will also increase. Therefore, the kinetic energy at 200 K is less than the amount of kinetic energy at 300 K. In the early 1900s, scientists developed a process to produce ammonia from hydrogen and atmospheric nitrogen on an industrial scale. The balanced equation below represents this reaction. At room temperature, the reaction occurs at a very slow rate. Therefore, the process takes place in a special reaction vessel at high temperature and high pressure. A catalyst is used to increase the rate of the production of ammonia. The reaction gases are cooled to remove the ammonia as a liquid, and the remaining gases are sent back to the reaction vessel. Explain, in terms of collision theory, why reacting hydrogen and nitrogen at high temperature increases the rate of reaction. As the temperature increases, the kinetic energy also increases. The molecules will then move faster and hit each other with more energy, increasing collision and increasing the rate of reaction. The key word in answering a question like this is to include that there will be more collisions. Determine the net quantity of heat released when 1 mole of ammonium gas is produced by this reaction. When 2 moles of NH3 are produced, 98.8 kilojoules of heat will be produced. By dividing the 2 moles of NH3 by 2 to get 1 mole of NH3, 91.8 kilojoules should also be divided by 2. This equals 45.9. Using the axes in your answer booklet, draw a potential energy diagram for the reaction. We must draw a potential energy diagram for an endothermic or an exothermic reaction. Since heat is released as a product, this is an exothermic reaction, so the heat of the products must be lower than the heat of the reactants. On your axis, you should draw a line, then goes up into a curve, and continue straight past the original line into a lower straight line. State, in terms of activation energy and reaction pathway, why the addition of a catalyst increases the rate of production of ammonia. The catalyst provides a different reaction pathway, which lowers the activation energy. In a laboratory activity, a student reacts an organic acid with an alcohol and produces a compound with a distinct odor. The incomplete chemical equation below shows the reaction in the laboratory activity with the missing product X. Identify the element present in the reactants that allows them to be classified as organic compounds. Carbon allows a compound to be classified as an organic compound. Write a chemical name for reactant 1. If you look at table K, it lists reactants. The answer to this question is propanoic acid or acetic acid. Write a formula for the missing product X in the equation. There must be an equal amount of each element on each side of the equation. On the reactant side of the equation, there are 4 atoms of carbon, 10 atoms of hydrogen, and 3 atoms of oxygen. On the product side of the equation, there are 4 atoms of carbon, 8 atoms of hydrogen, and 2 atoms of oxygen. X must be a compound with 2 atoms of hydrogen and 1 atom of carbon. This is H2O. Identify the class of organic compounds to which CH3, COO, CH2, CH3 belongs. Look at table R in the reference table to see which class of compounds it belongs to. This compound belongs to an ester class because if you see the example provided for an ester, which is CH3, CH2, COO, CH3, this is the formula of the compound given to us in the question, just moved around. An ester allows for 2 oxygen atoms to be present in the compound. Radioactive isotopes are used in a variety of ways. Several isotopes and their uses are shown below. Compare the penetrating power of the beta particle emitted from I-131 nuclide to the penetrating power of the alpha particle emitted from the U-238 nuclide. The beta particle will have a greater penetrating power than the alpha particle because it has a smaller charge. Complete the nuclear equation in your answer booklet for the decay of Fe59 used to diagnose anemia disorders by writing a notation for the missing product. In the answer booklet, it gives us Fe with an atomic mass of 59 and an atomic number of 26. In its decay, it is separated into a beta particle, which you can find in table O with an atomic mass of 0 and an atomic number of -1. The addition of the atomic mass and the atomic number on the product side should be equal to the atomic mass and the atomic number on the reactant side. 59 minus 0 is equal to 59, and 26 minus -1 equals 27. The missing element must have an atomic number of 27, which is CO, so we must fill in 59 CO 27. Determine the fraction of an original sample of the radioactive isotope used to test for thyroid problems that remain unchanged after 24.063 days. You should turn to table N in the reference table. If you find I-131, it says that the half-life is 8.021 days. Therefore, after 8.021 days, 1/2 of the sample will be left. Then, after another 8.021 days, or 16.042 days, 1/4 of the sample will be left. After another 8.021 days, or a total of 24.063 days, 1/8 of the sample will be left. Determine the number of neutrons in an atom of Am241. Go to the periodic table and find Am so that we can see its atomic number, which represents the amount of protons in an element of Am. The atomic number is 95. Then the atomic mass is 241U. The atomic mass is the total amount of neutrons and protons, so 241 minus 95 is equal to 140.